Hi, welcome back. This is the part of polynomial operations which involves the use of an old forgotten method called long division. And we're going to do a practice problem so you can kind of see how that works, and then we're going to utilize that practice to help us do the polynomial division. Now this is going to play a very important role when we get to rational functions, because this is the way that you determine if there is a slant or an oblique asymptote in a rational equation that you're trying to graph. So this does have a very critical role coming up very soon, so you are going to have to get a good grasp of this before we move on from here. Polynomial long division is long division that involves variables, and synthetic division is a shorthand method of polynomial division, but it only works when you're dividing by a linear factor in which the coefficient of the x term is 1. So let's brush off those cobwebs, which I'm sure are there. We'll be talking more about the remainder theorem as well. The remainder theorem is a polygon is divided by x minus k, then the remainder is f of k. We'll talk more about that as we're moving on. Okay, let's take a very simple division problem. Let me get my pen the right color. We're going to do 128 divided by 2. All right, using long division here, we use place value to help us stay in line where we're supposed to be, and 2 goes into 1 0 times, so I'm not going to use the 1, but 2 goes into 12 6 times, so above the 12 I put a 6. I multiply 6 times 2 to get 12. I subtract and I bring down the next number. I ask myself, 2 goes into 8 how many times? And then I multiply 2 times 4 to get 8. I subtract, my remainder is 0. So that is the process by which we're going to be doing long division today, and synthetic division a little bit later as well. All right, let's do some examples so that you can kind of see how this works. The first 2 examples I will do with you, and then you guys will do the other remaining examples on your own. Okay, the first thing I'm going to do is I'm going to say, how many times does x go into x? Notice what I did here as I rewrote this from a conventional division statement to an actual division problem that I can solve long division with. Okay? So now I'm going to ask myself, what number times x equals x squared? That's another way of saying how many times does x go into x squared? What number times x equals x squared? Well, x times x equals x squared. On top of the x squared, I will put that answer. Now I'm going to multiply the x to the x and the x to the 3. We're still multiplying by the outside factor. We're just not doing it once, we're doing it twice because there's 2 terms there. All right, so the first thing I do is x times x is x squared. X times 3 is negative 3x. This is the part where you're going to want to come up with a firm strategy to help you remember this process. Remember, we are subtracting this entire number. We're not just subtracting part of it, we're subtracting the entire thing. So that means that if I do it this way, I have to make the x squared negative and likewise make the 3x positive. The little mnemonic that I came up with to help you is when you draw the line, change every single sign. So that means what was positive is now negative, and what was negative is now positive. So when you draw the line, change every single sign. The way that you know that long division is working for you is that this term will always cancel out. It will always become 0. If it doesn't, you have made a mistake in choosing the number which x goes into. So now I'm going to do the same thing I've done before, and that's going to be 9 x plus 12. I'm going to start my division over again, and I'm going to say what number times x equals 9x. That's another way of saying how many times does x go into 9x. And the answer is 9. I'm going to again multiply by every number that's there, so that's going to be 9x minus 27. When I draw this line, I'm going to change every single sign of my term. So that means the positive 9 becomes negative and the negative 27 becomes positive. The way that you know that this long division is working is that these two terms will always cancel out. If they don't, you have made a mistake. 39, because there are no more terms to bring down, is my remainder. Now the way that I write my final quotient is x plus 9 plus 39 divided by x minus 3. And that is how you would write this particular long division problem in its final quotient form. Okay, in this particular problem, we've got some things that we need to address here. The first thing we've got to address is, oh, and I made a mistake in the way that I wrote it. The first thing we've got to address here is the fact that there is a third degree, a second degree, but no more degrees after that. That is going to be an issue because long division is based on place value. Each degree is a place value within this number system. So whenever you are missing a place value, you always have to write it in as 0. This becomes especially important if, for example, one of the degrees is skipped. So if this case was x to the third minus 4x, I would have to put a 0x squared in between. And now you can see where I made my mistake, so I will erase this and I will rewrite it as an appropriate division statement. X squared plus 0x minus 16. You always have to include those missing parts. If you don't, you are messing up the place value of the long division. Long division, regardless of what you're doing, whether it's this polynomial division or just numerically, is always based on place value. Okay, now that it is written correctly, now we can solve this problem properly. What number times x equals x squared, or x to the third? What number times x squared equals x to the third? That would be x. So now there's 3 terms, so I'm going to multiply all 3 times. Now you'll know that you've made a mistake by putting the 0 or not by putting the zeros in, because your place values won't line up. You'll have a squared where a cubed should be, or you'll be missing a term that should be added together, and you won't have like terms combined together. That's what the place value is all about. So that means I get x to the third plus 0x squared minus 16x. Now I'm going to draw this line and change every single sign. Minus, minus, plus. This cancels. I know I'm doing it right. That's going to be negative 4x squared plus 16x. I'm going to bring down my 0, and now I'm going to start over again. What number times x squared equals negative 4x squared? And that's going to be negative 4. I multiply it through all 3 terms, and I get negative 4x squared. That one's going to be minus 0x, because remember I'm multiplying there, and then that one's going to be plus 64. Draw the line, change every single sign. Okay, and now what I'm going to do is, notice it's still working, those cancel out. I get 16x minus 64. There's nothing left to bring down, so 16x minus 64 is my remainder. That means that the final quotient is negative 4x minus 4 plus 16x minus 64 divided by x squared minus 16. And that's how we'll do long division using polynomials. What I'd like you to do next is I'd like you to take an honest effort and try questions number 3 and question number 4. What we'll do here is I want you to pause the video and I want you to go through each of them. Once you've done that and you feel like you've reached the end, what I want you to do is continue on, because the next thing I'm going to do is I'm going to reveal the answers to question number 3 and question number 4. And that'll give you an idea about how close or how far away you are from understanding polynomial long division. All right, I hope that you took the opportunity to work through these. Your first answer should have been x squared plus 3x plus 6. And your second answer should have been x squared plus 3x plus 8, remainder 11x, divided by x squared minus x. Now we're going to use that shorthand method of long division called synthetic division. Now the synthetic division uses the solution to the factor. So if I solve this, I get x equals 2. If I solve this, I get x equals negative 2. So that will become my divisor in this particular problem. What we do in this shorthand method is we draw this little corner box like so, and then we write the coefficients of each of the terms of the polynomial that is being divided. We're careful to observe that each degree is represented. If any are missing, we need to fill them in with zeros. So that means in this case I get 1, the coefficient of x squared, negative 10, the coefficient of x, and 2, the constant term. Synthetic division tells me to bring down the first number. Always bring down the first number. Multiply below the line and then add up to the next line. So that means I go 2 times 1, which is 2, and then I'm going to add negative 10 plus 2, which gives me negative 8. Again, I start my process over again by multiplying 2 times negative 8, giving me negative 16. And then I add these two numbers together. 2 minus 16 is negative 14. The solution, the quotient to my problem is this one. The degree which I start with in my quotient is always 1 less than the degree of the dividend. So that means it's going to be x minus 8 remainder negative 14 divided by x minus 2. That's the solution, that's the quotient to this problem using synthetic division. Let's practice one more time. So we've solved this problem for x, and that's going to give us 2 as our divisor. And now I'm careful to go 3, 2, 1 constant, so we're good here. So it's going to be 1, 4, 6, and 4. I'm going to draw my line and bring down my first number. I'm going to multiply down and then add back up. So that means 2 times 1 is 2, and 4 plus 2 is 6. I start that process. Man, I didn't follow my own rules. I apologize for that. Let's erase this and start again. The number was negative 2. So negative 2 times 1 is negative 2. 4 minus 2 is 2. Multiply again. Negative 2 times 2 is negative 4. 6 minus 4 is positive 2. Negative 2 times 2 is negative 4. And 4 minus 4 is 0. The degree here is 3. So that means I begin with 1 less degree here. X squared plus 2x plus 2 with a remainder of 0. And that's my solution using my quotient using synthetic division. All right. Again, I'd like you guys to set up questions number 7 and 8. Give each of them a try. Go through the synthetic and see if you can get it. And then once you're finished, you'll be able to check your work. So pause the video now, and I will show you the answers as soon as you've completed your examples. Question number 7, the solution was 2x squared minus 6x plus 18. And question number 8 was 2x to the third minus 3x squared minus x with a remainder of 4 divided by x minus 4. So hopefully you've got a pretty good idea, a pretty good grasp of how long polynomial division and synthetic polynomial division works. We're going to have some additional practice in class tomorrow, so please come prepared tomorrow to be working on the back side of this sheet. We'll save all of these problems for tomorrow, so you'll have plenty to work on, plenty to practice, and we'll see if we can get the correct answers through long division practice and synthetic division practice. Again, if you have any questions, please do not hesitate to ask. We'll go over them tomorrow in class at the beginning. Additionally, at the beginning of this packet, you'll notice that there was an exploration piece that I kind of skipped over. We will address that exploration piece also tomorrow as a warm-up assignment at the beginning of class.